So today I'd like to go over video number 3 in that electromagnetism video series that you should be watching. Video 3 is all about the domain theory. And this video explains to you what creates that magnetism that something possesses. So in the beginning of the video, they talk about current carrying wires. So this is a very important aspect of electromagnetism. And the fact that a wire that has current running through it, so we refer to that as a current carrying wire. So you have these electrons that are flowing through the wire. So if we just consider a wire here with some electron flow, so my electrons are flowing in this direction. So my current would be traveling to the right in that diagram. A current carrying wire actually possesses a magnetic field around it. So at the beginning of the video, they talk about how when a compass needle or a compass itself was placed around above the wire in particular, that needle of that compass deflected due to that current that was traveling through the wire, right? So, maybe the compass needle moved in this direction, upward. And then typically the red end of a compass indicates north. It's kind of blurry there. But red usually indicates north, and then opposite that would be south. So the very important thing about this is to know that when a compass is placed around near a current carrying wire, that compass needle will deflect to show you the magnetic field. So a compass needle, when placed around a current carrying wire, compass needle will deflect to show or indicate the direction of the magnetic field. And so it's going to show you the direction that the magnetic field is pointing wherever that compass is placed. The next thing they get into in this video is iron. And so they looked at taking a coil of wire, right, and sending current through this wire. So we have, let's make this a different color, electrons. Let's have electrons flow up through this wire. And what they talked about here was inserting an iron core, right? So some iron bar placed right in here. So when iron is inserted in here, iron inside that coil produces something that is much stronger magnetically. So iron placed inside a current carrying wire, right? There must be current running through this current carrying wire, creates a stronger magnet. Okay, and this is actually called something else. It's called an electromagnet. Okay, and so this is where that term electromagnetism comes from. So this is becoming an electromagnet. So you have a magnetic field and a strong magnet that gets created because of that current and that electricity that's running through that wire. Okay. The important thing to realize here is in this same situation, when the current is shut off, the magnetic field disappears, it collapses. So when the current is shut off, the magnetic field disappears, right? It collapses. So your magnetic field will collapse, right? And it no longer acts as a magnet. Next part of the video got into what makes a magnet a magnet. And so this gets down into looking at the atomic level of a material. So this is really important to understand about magnetism. So most atoms do not possess a magnetic quality, right? So overall, most atoms do not have this magnetism about them. But what this comes from is the electron spin. So you know from chemistry, hopefully you kind of refreshed your memory here, that when you look at an atom, you have the nucleus where you have your neutrons and your protons, and then orbiting outside the nucleus, you have your electrons. And the electrons, you can kind of think of them in maybe the Bohr model, where you have them in rings around the nucleus. Those electrons orbit the nucleus, but as they're orbiting the nucleus, they also spin around themselves. So this is kind of like the Earth, right? So you can think of this using the analogy of Earth. So the Earth, you know, orbits the sun. But as the Earth orbits the sun, the Earth also spins around its axis. And so electrons essentially do the same thing. They're going to orbit that nucleus, and as they're orbiting that nucleus, they are spinning around themselves. And that spin, this spin, generates a magnetic field. Okay? And so that spin of that electron as it's orbiting generates a magnetic field. Now, most atoms do not possess a magnetic quality because that one spin of an electron will cancel with the spin of another electron. Right? So when they spin in opposite directions, those magnetic fields get canceled out. However, iron is a big exception, right? So iron is an exception to the fact that those magnetic fields cancel. So iron is an exception, okay? Because iron has 4 more electrons spinning in the same direction that are not canceled with any other electron. So iron naturally has a magnetic quality about it. So these electrons spinning in the same direction generate a tiny magnetic field. So iron is something that you should know that has this quality. Nickel and cobalt also possess this. Right? So iron, nickel, and cobalt also, those two others, nickel and cobalt, also have what we call magnetic dipoles. So these also possess extra electrons spinning in the same direction that are not canceled out. And we call these ferromagnetic materials. That's a word that you'll hear a lot. So these 3 things are ferromagnetic. Right? And that indicates to you that they have these electrons that spin, generating a magnetic field, but they are not canceled by an electron that's spinning in the opposite direction. Okay? These again are referred to as magnetic dipoles. Okay? And that means they have 2 poles, right? Dipoles meaning they have 2 poles, a north pole and a south pole. So north and south. The next part of this video gets into what happens when those electrons spin in the same direction and they align themselves together. So the last part of this is all about domains, and I'm going to try and keep this on the same sheet of paper, so I'm going to come up here and continue to talk about domains. Okay. So a domain is something that you'll want to know what it means, but also kind of how to draw a domain. So a domain are clusters of dipoles. Right? And so remember what a dipole is. We talked about that down here. Dipole is something that has 2 poles. So a cluster of dipoles that all align in the same direction. All aligned in the same direction. So that means that your electron in that domain are spinning in the same direction. Okay. When all of those domains point in the same direction, you are going to create something that's a magnet. So when you have domains that are aligned, so aligned domains, you create a magnet. Right? So I'm going to draw a couple pictures that hopefully will help you understand this. So here you can think of this as a bar magnet, right? Something that's just rectangular. Now, a domain is a section of this, right? A cluster, where all of the dipoles are aligned in the same direction. So we could say in this section of my object, all of my electrons are spinning to the right. So I'm just going to put an arrow to the right. In this section, all of my electrons are also spinning to the right. So I'm just going to section this off and say that all of my electrons are spinning to the right. And so every one of my domains is aligned in this diagram to the right. So I've created something that is a magnet. So this diagram shows you something that is acting as a magnet. When you have unaligned domains, you have something that is non-magnetic. So I'm going to draw the same rectangular object here. And we have domains. So I'm just going to break this up into different sections. Right? There are my domains. And within a domain, all of the electrons are spinning in the same direction. So I'm going to say in this top left-hand domain, everything's spinning to the right. But in the domain that's underneath that, let's say everything's spinning down. And over here, let's have it spin at some angle. And then down here, we'll spin up and we'll spin left, off at this angle, and down like this, and over like that. So here you can see my arrows that indicate the direction of the spin are unaligned, right? They are not all pointed in one direction. So this is a diagram of something that is non-magnetic. The very last part of that video gets into steel, right? And what happens when you have steel. Steel actually inhibits the ability of iron to return to this random unaligned domain. Right? So steel is unique. Steel keeps things magnetized for longer periods of time. Right? One way to demagnetize this is to heat it up. Right? So when you heat something that's magnetic, those domains are going to unalign. Or what you can do is bang it, right, repeatedly. So if you drop magnets, they typically will lose their magnetism because you are unaligning the domains that create that magnetic property.